Question 41, you're given information about a cooling cup of coffee. Now, you're asked to show that this does form a geometric sequence. So what I can do, I can compare the ratio of T2 over T1 with T3 over T2. It's only necessary to compare two. And when I do the division, and likewise when I do the division for the second comparison, I've got 0.75. So clearly the common ratio is equal to 0.75. So the rule for the sequence, (64) was the first measure. Now when you organise that, please make sure that you separate your numbers, and when we enter that as an equation on our calculator, make sure that you're entering it as times 0.75 and then raise it to the n-1 power, like so. Now you can see here 64, 48, etc. I would normally find T6 by going 64 times 0.75, the power of 5. But you can see I would get 15.188 degrees Celsius if I did that. And likewise, if I continue the question, I can scroll down and find the temperatures. Notice that this is forming an exponential decay type situation. And if I looked at the graph, you can see, and I haven't illustrated everything here, you can see the exponential decay occurring like so. It is possible, using the graph analysis tool, to trace and just tab along and see what's happening with your numbers as you progress through. Working the rest of that problem, you can see that after 15 minutes, 64 times 0.75 to the power of 14, that gives me 1.14 degrees Celsius as confirmed on the table. Now we're also given some additional information. We're told if the temperature, room temperature, was actually 18.5 degrees Celsius, the actual temperature is going to equal the 18.5 plus the 1.14, and that will give us the 19.64 degrees Celsius. Still trying to work out how they found the 1.14 if the temperature of the room was like that though. Please get used to using the functionality of your calculator. It's a very, very powerful tool, and we can flip between entering the nth term form and the term, and also the sum of those terms if and when applicable.